Guess what? It's time for class. It's time for arithmetic class. Let's begin with a little bit of a review, and then we'll go on to the new material. Are you ready? Let's review. We know that that is a square, especially the corners of square. What are those? Parallel lines. Good. Intersecting lines. That is a what? A what? A simple closed curve. For now, we're just going to call that a polygon. Polygon is a figure made of line segments. Good. Intersecting lines. What kind of intersecting lines? I should say perpendicular lines. Good, because it's making right angles. Congruent angles. Oh, what is that? A right angle. Did you say ray? Line. Is that line segment where the dots are? It's from this point to that point. And of course that is a point. Good. Angle. All right. And we'll do some more the next time. I think I'm going to flip it around the other way. Give me the decimal equivalent. What would that be? 0.001 or 1/1000th. 3,000th would be what? 0.003. 21,000th would be what? 0.021, right? 0.021, 21,000. 111,000th, so it would simply be 0.111. Who's getting these? Are you all getting these? 4,100ths would simply be 0.41. So hopefully you are continuing to excel with those. How about reducing problems? Reducing fractions. What was that one? 10/15ths would be what? Did you say 2/3? Is that proper or improper? It's improper. So what should it be? 3, right? 9 goes into 27 3 times. 1/3. 1/3. 1/4. Are you saying them? Do you know them before I say it? Did you say 2/3? 1/4. 1/4. 1/3. How fast are you getting at those? Do you know them that quickly? 5th grade is coming soon, and you'll want to be able to do those rather quickly by then. So if you are able to do it, you're doing a super job. If not, keep practicing them. Make yourself your own cards, and you can keep practicing those even throughout the summer as we get closer to that time. Together. 1 minute equals 60 seconds. 1 foot equals 12 inches. 1 yard equals 3 feet. 1, what's that? 1 quart equals what? 2 pints. Okay, that's one that we want to keep remembering. 1 metric ton equals 2,200 pounds. 1 meter equals 1,000 millimeters. 1 kilometer equals 1,000 meters. 1 decameter equals 10 meters. 1 hectometer equals 100 meters. 1 meter equals 10 decimeters. 1 dozen things equals 12 things. Good. Who got all of those right? I hope you did a super job. Now we're simply going to dive right into what we've been talking about. We've spoken and worked perimeter. We've done the perimeter of, it could be a rectangle, it could be the perimeter of any object, a triangle, A plus B plus C, which is different because all the sides, now you could have equal sides, but they could all be different lengths. We've done more particularly the rectangle and square, where the rectangle has two sides that are the same, two sides that are different, and a square, all you need to know is one side, and then use the formula s times 4, right? Or 4 times s, or side plus side plus side plus side, since there's 4 sides in a square. Or you could do the the perimeter of a rectangle, or we could even say a parallelogram where there are 2 sides that are the same and 2 sides that are different. And we could simply go length plus width, or 2 times the length plus 2 times the width, and memorize the formulas and get the correct answer. Perimeter is the distance around something. We could go out, you know, the cage that we often called at recess time, we could go around that cage and walk the perimeter of it. We could walk the perimeter of a building. You could go outside your house and walk the perimeter. You could measure the perimeter of your whole house and measure all the way along this way, all the way along this way. You probably want it be slanted like this shape is, but you could do that. You could go inside one of your, let's say one room in your house, and you could find the perimeter of that room. Oh, it's 12 feet by 10 feet, or whatever it is. And that's the perimeter of that. And you could go 10 plus 10 plus 12 plus 12. It's if it were an actual rectangle shape, and find the perimeter. Well, that's the distance around perimeter. Today we're going to go on though, and we're going to talk about something called area. Now, area is the distance inside, not the distance around. This is the perimeter, right? That's the perimeter. But what if I wanted every spot in between inside the shape? That's the area. All the space inside. Perimeter is how far along the outside. Area is inside. How do we find all of what's inside the shape? So here's a simple shape. Now I could count up all the squares. Let's say these were inches, or they could be in feet, whatever unit that you want. I could count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could count them all up and find out how many square feet. Which, by the way, the units are always square units. So you're going to learn that, and I'm going to just put SQU, or SQ, you could also do square feet, square yards, whatever it is, the word square will be there too. With perimeter, you don't use square units, but for area, you use square units. But a simpler way than just counting up all the squares would be, how many squares are across this way? Across this way, 1, 2, 3, 4, 5, 6. I'm going to write a 6 there. How many squares are this way? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 squares along that way. What's 8 times 6? 48. And I could say that's 48 square inches or whatever. I could say there's 48 square inches. So when I count them, I can count them, how many are that way, and I can count how many are that way. Now, you can, that one that you counted at the bottom, and then you count it this way, you can count it again, all right, because there's 8 that way, and there's 8 that way. So don't think that, oh, I already counted that last one at the bottom, so you still can count it this way too. And then just multiply, and you can find the area of an object, or you can count them all. And that's what you'll do on your paper today. You'll find out how many in that shape there are. inside the shape. This comes to the practical. Why would you need to know how to do this? Inside your house, you're going to buy some carpet for your room. And if it was this long one way and that long the other way, you'll know how many square feet or square inches you need to find it for. So you'll know how much to buy. Oh, if your room is 12 feet by 12 feet, 12 times 12 is 144. That's real easy. It's a square. I need to buy 144 square feet. See, to find how much carpeting I need for that room. So this is very practical. People use this every day, all the time, to solve everyday situations. For example, how much to buy? How many floorboards do I need to put down, right? How much tin do I need to put on the roof or shingles, right? How many do I need? And there's a way of figuring that out. But what if it's an odd shape like this? Can you figure this out? Well, again, I could count all the squares, but I don't want you to. I want you to figure it out because it just take a long time. This is quicker and is better. So when you get to a shape like this, think of squares and rectangles. How many different squares or rectangles could I make out of this? Well, this is one there. This is one here. This is one here. And actually, I don't even need to put that line there, do I? I could say, here's a rectangle here, right? Long one. Then there's a square here, right? And then there's one on the end. So I could actually, I'm going to go like this. I could divide one there. I could divide a square here. And then there's one long rectangle there. So there's actually three. I didn't have to do that on that one. I actually don't need to do that one, do I? So there's actually three shapes. There's a square here. There's a square up here. And then there's one long rectangle here, right? One long rectangle here, okay? And I find the area of each one. And that's how I'd solve that one. So I could go, well, there's 3 across this way and there's 3 across that way. So the area of this square is 9. What about this? Same thing. There's 3 this way and 3 that way, right? 1, 2, 3, and 1, 2, 3. So the area of this one is also 9 because 3 times 3 is 9. Well, what about this long one? It's 3 this way, right? It's 3 this way. And then how many this way is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's 12 times 3? Ooh, this one's going to be 36. The area of this shape is 36. So to get the entire shape, I could add 36 plus 9 for this part, plus 9. And I could get a total, and that would be the total area. Let's say it were inches, and I'd put square units. Now, you don't need to know exactly how to do that yet, but it's good for you to get an idea of it now, so that when you do come across it, you can do it. You can go, or you can add up all the squares. And that's the area. Maybe this was an odd-shaped building, and you could figure out how many feet it was. Well, if this was 36, and that was 9 for that addition there, and then this part here was also 9, I could add them all together. 9 plus 9 is 18. Plus 6, 24. 2 plus 3, 5. And I could write, for my answer to that one, I would write 54 square feet We're just going to make it simple and say feet. That would be the answer to my area problem. See? Now in the next lesson, we'll actually learn a formula for doing that. For now, just know that the number of squares equals what the area is for that shape. Squares and rectangles. Think of squares and rectangles in different sizes in order to solve the area. You have any questions? It is in your book on page 285. 285. Do that paper for today. That's for lesson 158. If you have any questions, let me know. But you probably can figure it out by watching this video again or looking in your book and just reading what area is. Again, it's not hard for today's. Tomorrow's, you'll go into it a little further, we will. For now, do your best, do a fantastic job, and go ahead and do your paper. Are you talking? Go ahead and do your paper and have a fantastic day. And be looking for the next video. Bye for now.